All right, guys, so we're going to keep talking about arcs, and we're going to see how they relate to chords. Remember, chords is a segment with two endpoints on the circle, and definitely a diameter is a chord. So if I draw my circle here, I have like point A and point B. They connect together, that's a chord. Okay, so anything that connects inside the circle is a chord. This is not a chord until it shows these points, and you can name it as a segment. So remember, it's always like segment AB. A lot of people had problems with that. So we're going to talk about a theorem today. It's a pretty easy one to understand. Reading it's not so fun. It says, in a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Let's look at this figure right here. It's going to ask us some questions. We'll answer them in a second. If I see this chord AB, it is congruent to chord CD. And what that means is that the arcs that they represent, like this one and this one, are also congruent. So that's what it's talking about. So let's see, it says, which two chords are congruent? Well, we already kind of wrote that down. That's going to be chord AB and chord CD. So they're the same. So it says, which two arcs does that make the same? Well, that makes the arcs they cut the same. So arc AB and arc CD. So that's pretty easy. Now it says, what are the measures of their arcs? Now, if I look out here, I know pretty much everything else but those two arcs, but I know they're the same, so I'm just going to call them X. And you could work it a different way if you want to. So I'm going to say I have two X's plus 220 plus 20, and that should equal the total 360 degrees. Now I can just solve this. That's 2X plus 240 equals 360. Subtract the 240, 2x equals 120, and then I divide by 2, and I get that x equals 60. So the measure of each arc is 60 degrees. So it's pretty easy theorem in practice. We'll see a lot of examples about it today. Now the next one I think is a little bit tricky, so stay with me here. It says, if from P to S, now these are the lines, they're not talking about the arcs, they're saying the length of PS is 12, and the length from T to R is 15, then find QR. So it wants us to find this length. So we might need to kind of look at some stuff. This one, RQ, has an arc length of 70 degrees. If we had another arc of 70 degrees, that chord would be the same length as RQ. Well, if I look over here, I know that from P to T it's 20 or 50, and from T to S it's 20. And I know if I add those together, I get 70 degrees. So that's 70 degrees. So is this one. So that means this line that connects P to S is the same as this line that connects R to Q, meaning QR is 12 units. So that's kind of weird because they definitely don't look the same length in our picture, but that's what the numbers tell us. So make sure and kind of check that stuff out. I could have tried the other one, T to R, but that would have given me 80, so that wouldn't have helped me at all. Let's look at the next page. Same sort of problem here. It's asking me to find the length of chord HI. This one right here. That's in black, so you may not be able to see it. That one right there. And it gives us everything else. And there's really nothing we have except for, I know all the angles around the circle except for the one that has that chord in it, HI. So if I can find that, maybe I can answer my question. 360 minus 113 minus 91 minus 78. If you do that, you end up getting 78 degrees. So what that means is if this chord and this, or I'm sorry, if this arc and this arc are the same, then their chords are also the same. So HI is going to be 9 units. We got another theorem here. It's a pretty easy one too. In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord at its arc. So if I look at this one, I've got a radius cutting into a chord perpendicularly, so that means this. Well, that means it cuts these in half, okay? So I think answering the next question, it's a lot easier if you just start filling out the circle and coming back to it in a second. So AD is perpendicular to BC. We marked that. A to E is 12. The radius is 13. So AD is a radius. I'm just going to go ahead and write right here that that's 1. And just I'm going to remind myself radius is 13. Now it starts asking us stuff, and there's some stuff I can figure out and some stuff I can't. I do know a couple of things. I know that these are all right angles, so maybe that'll help me in a second. But let's see what they ask us for. ED. Well, E to D was easy. We accidentally found it anyway. It's 1. Because if A to E is 12 and A to D is 13, then we'd have to subtract. See what they got next. A to C. Well, A to C, and they're going to ask us A to B also in the next one. So I'm just going to kind of sketch those in. They're not really there. But you should notice that they are the radius. It goes from A to B to the circle. They're the same length as AD. AD is 13, so that means that these are also 13. Then we go to EB and EC. So these out here, I need to find this and that. Well, they make a triangle. So here's the bottom that we need to find. We know this is 12. We know that's a right angle. And this is 13. So we have Pythagorean Theorem. A squared plus 12 squared equals 13 squared. Now this is a triple. It'll always work. If you have 12 and 13, then the other one's going to be 5. So I now know that E to B is 5 and that E to C is 5. Then they ask the really tough question at the end, how long is it from B to C? Well, we add those up. You should get 10. So that's kind of a long problem, but really it wasn't very tough. You just got to remember those right triangles, Pythagorean Theorem. Next one, same sort of thing. It says if the measure of arc CFB is 220 degrees, so C to F to B, that's 220 degrees, wants us to find the following, and that tells us a lot on its own. If that's 220, then everything left, when I subtract from 360 is the other part, I get that to be, and I'm going to do it in red here, this arc right here looks like it's 140 degrees. Now, if you remember up here, it said that it bisects the chord. So that's important here because I know these are equal length, which means these arcs are going to be the same. So I'm going to divide 140 by 2, and that gives me each of these arcs is 70 degrees. Then remember that's because the radius bisects that chord. So let's see what they ask us. Arc CB, we just found it, 140 degrees. Angle CAB. They want to know this whole angle there. Well, guys, that angle is the same as its intercepting arc, so I know it's 140 degrees. Now they want angle BAD, so just this one, well, its arc is 70 degrees. And obviously we had CD, arc CD marked as 70 degrees as well. All right, let's go to the last page. We're almost finished. Full length. Whoops, sorry. It says in example, or in circle A, SQ is 12. So I'm going to put 12, but really I'm just going to write 6 and 6. It makes it a little bit easier, I think. It says A to T is 8. It wants us to find A to R. So I want to know this. I want to know this whole length right there. So it's kind of tough to tell, but and maybe you wouldn't think about going this way. Some people may want to try to find the length of this, but that's not going to work very well. What you need to remember is this is a radius, so is A to S. And I have a right triangle that uses A to S, and I know the other two sides. So I need to find this one over here, knowing that this one's 6 and this one's 8. So you should know that from Pythagorean triples. 6 squared plus 8 squared is 100 squared. Square root of that is 10. So AR is 10 units. So it's a pretty easy one, but I could see where you might think to start there. So look for your right triangles. Using the diagram below, find the indicated values. This one's got a special right triangle in it. It's a 30, 60, 90. So that means this is our x. This is our x square roots of 3, and this is our 2x. So if 2x is 6, then this side's 3. This side's 3 square roots of 3. So let's see what it asks us. What's the distance from A to D? Well, we already found it. 3 square roots of 3. It asks for from C to D. We found that too. It was 3. Then it wants the measure of arc AB. So this whole thing right there. Well, these have to be congruent, which means we have congruent triangles. So if I just pull that over there, I know that's 60 degrees as well, which gives me 120 degrees for the whole thing. All right, our last theorem of the day. In a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So remember, equidistance means the same distance. So like this picture right here, this chord is the same distance from the center as this chord, and that's what it's telling us. So it says, find the values of x and y. Well, that's pretty easy. I know if a radius hits the chord perpendicular, then it makes them congruent, which makes x be 8. And if these two lines right here are congruent, that means that the chords are congruent. And this chord has two 8s on it, so that would be 16. So pretty easy, pretty quick. Last one in circles O, FL is 3. See, FL is 3. GO is 5. OP is 4. It says find HJ. Well, we have a lot of congruent things going on here. Like, let's see, we have our right triangles in there. This is a radius, so that means this is a radius, so that must be 5. If this over here is 3, so's that. If this is 3 and this is 5, Pythagorean Theorem says that's 4, which means this is 3, which means that's 3. So we had a lot of stuff pop up there. I went through it kind of quick, but you can ask me if you want to. And then it asks us for how long is it from H to J. Looks like it would be 6. So guys, that can be a little bit confusing. If you have any questions, just let me know in class. Good luck.